Yes? It will not. What is the force of friction? See, force of friction is 0. How is it? It's not coming down. Okay. Okay. So see what is happening in this situation. 500 newtons of force are applied like this, so it will have two components, right? If this angle is theta, this will also be theta, and therefore this is going to be 500 cosine of 30, and this will be 500 sine of 30, right? Isn't it? So we have a force which is actually 25 times 10, which is 250 newtons, which wants to bring this body down. How much is this force? This is also 250. Do we need friction? We do not. Therefore, the body is at rest. Friction is not utilized. Understand. Don't say, sir, force of friction is equal to mu times normal reaction, which is 0.2 times normal reaction. In this case, is 500 root 3 by 2. You cannot use this concept for. This is the maximum capability, but it is not utilized here because the body is not in motion. Understand? It is at rest with the help of the vertical component. However, if you take the value of G as 9.8, if it is not mentioned, then please, yes, there is going to be some situation. Understand? In that situation, 500 sine of 30 will be up. 250 will not be down. 249 point something because 9.8 the value of G. So this force is less. Upward is more. The body is going to go up. Correct? And the difference of the two forces will be the force of friction, and that force of friction will be downwards. Is it fine? Clear? Okay. After the break, we will do one thing. We'll apply the force of friction on an inclined plane. Fine? Okay. Let us now talk about some other things. Say, for example, there is a wedge, and the angle of the wedge is theta. Fine. And there is a block of mass m. The coefficient of friction is mu. Fine. Now, this angle is more than the angle of repulsion. Okay, so that means this is definitely going to go. Now, in order to stop this block, fine, what do we need? A wire. In order to stop this block, definitely we need a force which will not let it come down. That can be a wire. Okay, it's fine. So, there are actually three possible ways in which you can stop it from coming down. This will definitely come down, right? So, if you talk about the forces, see, mg is acting downwards, isn't it? And then you will have two components. One will be here and the other one will be here. If this is theta, then this angle is also. So this is mg cosine of theta, isn't it? And then we have mg sine of theta, right? Now mg sine theta is so strong that the force of friction, which is actually acting upwards, isn't it, cannot hold it back. And that is why it is coming down, right? So in order to stop this block from coming down, we require force. And what are the possible ways in which you can stop it? How do you apply that force so that it doesn't come down? Increase the roughness of the surface. Okay. Anything else? We can attach. Okay, we can attach a wire. Okay. Move the block left. Yeah, that will make sense. So first of all, do you all agree that the force of friction which is being utilized here is the limiting friction? Isn't it? That is the maximum possible friction which is operating. Why? Because mg sine theta is more. Correct? Okay. Now, in order to stop this block from coming down, technically we have three methods of applying the force. First is you can apply a force like this. Isn't it? And stop this block from coming down. We can have another method in which you are applying a force on this block like this, isn't it? What will happen due to this force? This is actually increasing the normal reaction, which in turn will increase the force of friction, and therefore we can stop it, right? We have one more method actually, in which you can stop this block from coming down, and that is by applying the force horizontally, which will have two components. One will be along the red, and the other one will be along the green. So this has actually increased the chances much more as compared to these individual forces, right? Why? Because when you're applying the force in this direction, normal reaction will be increased and this will also be increased, right? Let me discuss one of the cases. Let us see what is going to happen. Fine? Let us discuss the first case when the force that you're applying is along the red direction. Along the incline but in the upward direction. Is it fine? Okay. So here is a block over the wedge. The angle of the wedge is theta. mg is acting downwards and it has two components. This is mg cosine of theta and this will be mg sine of theta, correct? And because the wedge is, the block is still coming down, that means the force of friction, which is the limiting friction, is acting in the upward direction, right? Now, in order to stop this block from coming down, we require certain minimum value of force, isn't it? That minimum value of force which will be applied so that this block doesn't come down will be this F min, isn't it? Isn't it? Can anyone tell me what will be the value of F min? So, can I say F min will be equal to, yes, will it be mg sine of theta minus Fl, that is the maximum value of friction that we have, and that value of friction Fl is equal to mu times the normal reaction, which is mg cos theta, isn't it? Correct? So it will be mu mg cos of theta, correct? This is the minimum requirement. If the force is less than F min, what will happen? It will still come down. What if the force that you are applying is a little more than F min? Yes. If F applied, understand, is less than F min, the block will come down, right? But what if the force that you are applying is more than F min? What will happen? The block will go? The block will not go. Understand. The block doesn't have the tendency to go up when you're increasing the force. Why? Because understand, friction is the last help. This block actually wanted to come down because of what? mg. You are, for example, 10 newtons of force. Now you are applying the force of friction was only 8. What was the requirement? 2 newtons. Right? So you are applying 2 newtons from outside and this block is at rest. Right? Now what if you are applying 3 newtons? When you are applying 3 newtons, understand the force of friction will reduce. The force of friction in the first case was at limit. We were using 8 newtons of friction, right? But once you are applying 3 newtons, the friction doesn't need to utilize itself. The force of friction which is operating in the system will reduce. Is it fine? And the block will not go up. Is it clear? It will still be at rest. Fine? So that means that the force applied is more than the minimum force. Then remember, the force of friction which is operating in the system will decrease. Is it fine? And the block is still at rest. It will not go up. Clear? The force of friction which will be utilized will be mg sine theta minus the force. The force, the operating friction which will be used in this case will be, yes, it will be mg sine of theta minus the force that is. Is it fine? It will not be at its maximum value. Understand what is limiting friction. It is unlimited. But that limit is only utilized once I have lost all my resources. I now have a resource, right? I now have a resource. Now, once I have the resource, this block will not go up. The force of friction which was being utilized out of the total will be reduced. Clear? What if you will further increase the applied force?
If F means limiting friction.
So. We will reject that. What if you are now, I said the applied force is a little more than. What if it is much more? What will happen? Again, the same thing will happen. The force of friction will be decreasing. The friction which is operating in the system will reduce. Like in the previous case, when you are applying 500 newtons like this. Friction was not utilized, it was only the external force which was keeping the block still. Right? So in this case, exactly the same thing happens. When you are applying the force and you are increasing it beyond F min, the force of friction will continuously reduce till it becomes 0. There will be a case, say for example, this was 10 newtons, the force of friction was 8 newtons, and you are applying 2, correct? Now you are increasing 3, 4. The moment you are increasing the applied force, the force of friction reduces, till your external force becomes equal to 10. Till it becomes 10, the force of friction will become 0. Will the block have tendency to go up? No, it is still at. The operating friction will be. So next case will be if the applied force becomes equal to mg sin theta, the operating friction in the system will be 0. We don't need friction, the block is still at rest. Understand, very important thing. The block is still at rest. Now the question is, if the applied force is more than mg sin theta, what will happen? Will the block go up? No. The force of friction will reverse its direction. Understand friction, please. See what is happening. See. You are increasing the force. Force is in, what was the maximum value of mg sin theta? 10 newtons. Huh? It was 10 newtons, for example. And the limiting friction was, for example, 8 newtons, right? How much did we require? 2 newtons. So 2 newtons, 3 newtons still at rest. 4 newtons still at rest. But what is happening? This is reducing its value, correct? Till it becomes 0. So when you are applying 10 newtons, this becomes 0. The block is at rest. Now the moment you are increasing the force, you are giving 11 newtons. Understand the concept of friction. The frictional force opposes the relative force. Now this block has a tendency to go up. The force of friction will tell you, oh, I'll reverse the direction. Understood? So force of friction will be in this direction. This was mg sin theta, correct? And you are applying a force F, which is greater than what? Mg sin theta. Understood? Right? So in that situation, the force of friction now has reversed its direction. Yahan se lagega. Will the block go up? No, it will not. It will not. You keep on increasing F. Will it go up? No, it will not. Why? Understand. Understand. This was how much? 10 newtons. For example, you applied 11. Will it go up? No. Why? 11 will oppose 10, and the 1 newton will be opposed with friction. Friction will become self-adjusting. समझ रहे हो? Friction 1 newton down. Right? You are making it 12 newtons. What will happen? 10 is already there. Friction will self-adjust to 2 newtons. You are increasing it to 13. Friction is 14, 15, 18. Exactly 8 newtons. When you are applying 18 newtons from outside, till 18 newtons are attained, will the block go up? So it means when the applied force is more than mg sin theta, the block is still at rest. Correct? The force of friction has reversed its direction. Correct? And the block will not go up. Till when will the block not go up?
Overcomes.
Exactly. So that means if the applied force is equal to or less than how much? mg sine theta plus the limiting friction. Isn't it? Until and when the applied force is mg sine theta plus something and it is less than this combination, remember the block is not going to go up. It will remain at, because the friction will self-adjust, right? The maximum weight of friction was 8. This was 10, 18 newtons. Still it is less than 18 or more than F that we discussed in the previous case. This mg sine theta, less than 18 but more than mg sine theta, understand? Less than 18 and more than, till then the block will still remain at this. But the moment this applied force, yes, goes beyond what? mg sine theta plus FL, isn't it? In that situation, the friction now has lost it. And thus the block will definitely go. Is it clear? Is it clear? So can you sum it up? The force of friction is changing its direction depending on the relative motion. The block is not going to go up no matter what until and unless this situation is